Okay, so today's problem is basically, Will, you gave me this one. You need to factor x squared plus minus 12x plus 35 equals 0, right?
Right.
Okay. The first thing you're going to want to do is you're going to want to try to find all of the possible factors that you're going to want to try to find all the possible factors for 35 in here to be able to give you an idea as to what you're looking for. So that's going to be plus minus 1. I can't draw and paint. This is a pain in the rear. Let me try this again. Okay, so you're looking for, as I was saying, why I literally just clicked. Oh, there we go. So plus minus 1. No, okay, for some reason that's not working properly. Okay, come on. Damn it. Of all the times for my computer to have it had to be now. So plus minus 1. Oh, come on. Hang on, I'm gonna close paint. I'm gonna close paint and restart this, and we'll try again. No, I don't want to save changes because this is a stupid program that's deciding to be a pain in my ass. All right, let's screen share it one more time and try this again. Okay, so here we go. This is going to be x squared minus 12x plus 35 equals 0. Okay, so the first thing that you're going to want to do is you're going to want to find all of the common factors for 35. So that's going to be plus minus 1, comma, plus minus 5, comma, plus minus 7, and comma, plus minus 35. Now, the first thing you're going to want to do is you're going to want to plug in. The first thing that you're going to want to try to do is that now that you have these common factors, you're going to want to at least you're going to want to try to find you're going to want to plug each of these into the equation and basically see whether or not they actually equal 0. Now, for shorthand of this particular point, I'll tell you that basically for this particular one to work, minus 5. That's going to be hold on. Yeah, x squared. So that's 5. That's 25. So just let me grab a calculator up here to just to show what we're doing here. So that's going to be negative 5. Where's the negative button? There we go. So negative 5 squared minus bracket 12 times negative 5 times 5 negative bracket plus 35. Oh, damn it. Did I screw that up? I think I might have. Oops. So, hang on. Damn it. Let me. X minus.
Yeah, I got 7.
Okay, so yeah. Pardon? Yeah, sorry. So that's why it's positive 5. Sorry, right? It's positive 5. So that's why you set it to minus 5. Sorry about that. I made a boo boo. Let's try that again. So 5 squared. So you try that. You try 5 squared minus 12 times 5. Sorry, minus bracket 12 times 5 gets you equals negative 35 plus 35 equals 0. So you know that 5 is one of your factors, right? Now the thing, of course, is though is that because of the way that the factoring works, we can now set that to equal the first one as x minus 5. Because of the fact that your value plus 5 is one of the ones that fits the equation, that can be one of your factors, but you set it to minus 5 because it basically for the equation to go for the equation to go 5 to the right, it has to be written as -5 for notation reasons. But now, because of the fact that you've got your first one, you now have to figure out which one of your equations gets you to -12. Well, in this particular case, we know that -5 and -7 add together to make -12. So now you get thus giving you x minus 5 times x minus 7, which will work out to, when you do the basic brackets first, outside, inside, last, to x squared minus 7x minus 5x plus 35. And that gets you your equation. X squared minus 12x plus 35. And so basically what you're looking for here is that in order to be able to do a factoring job, you try to find all of your possible factors for the very last number, and then plug those into the equation to see which ones actually work out. And then it's basically you write your equation as x minus blank if it's a positive, or x plus blank if it's a negative. Does that make any sense?
Well, a little bit.
Okay, well that basically kind of gets you the rough idea now of how to. That kind of gets you the rough idea of at least how to factor this equation and do most basic factoring for quadratics, assuming you're not looking for the roots. If you're looking for the roots, that's a whole other formula.
All right, so let's try this one. X squared minus 4 is 32.
You said
so
x squared. Sorry, you said x squared minus.
Yeah, x minus 4x 32.
Minus 4x. Was that a plus or minus 32?
Minus.
Okay, so x squared minus 4x minus 32.
Right.
Okay, so 32. So running the same. Running the basic same scenario here. For this one, we'll basically run the possibles for 32. That's going to be plus minus 1. Oh, damn it! Now I have to start erasing crap. No, not to worry. I'll just make it work. Plus minus 1, comma, plus minus 2, plus minus 4. 4 times, yeah, so that's plus minus 8, plus minus 16, and plus minus 32. Okay, so now for these ones, I'm actually going to literally have to do this manual punch in. So this is going to take a sec. And what we'll do is I'll just we'll literally just go through each one of these and see what happens. That's going to be 1 minus 4. So 1 minus 4 minus 32 doesn't work. Negative 1 squared is just 1 plus 4 minus 32, so that doesn't work. Let's punch in 2. 2 squared, 4. 4 minus 16 equals negative 12. That doesn't work. So let's try negative 2. Negative 2. Sorry, 2 negative squared. Minus bracket 4 times negative 2. That's still 12, so that doesn't work. 12 minus 32 is not, okay, so that's not it. So now we bump to 4. And so now we keep going and we bump to 4. 4 squared. 4 squared minus 4. So 4 squared minus 4. 4 squared minus 4 bracket 4. Sorry, 4 squared minus 4 bracket 4. 4 times 4. Okay, that's actually goes to 0. So we're looking for minus 4. So I'm worried about we're looking for minus 4 on this one. So that's going to be minus 4 squared. Or I'm just keeping punching these until I find one that works. So 4 negative squared times, or no, not times, back. Damn it. Okay, so 16 minus 4 times negative. That's going to get us 32 minus 32 equals 0. So the first one that we're going to have, so our first factor is going to be, so our first one that actually went in that worked properly is negative 4. So that's going to give us x plus 4. So now we have to go. So now we have to figure out what multiplies with 4 to get negative 32, but we'll plus to get negative 4. So that actually should be relatively easy because we know that 4 plus negative 8 equals negative 4, and 4 times negative 8 equals negative. 4 times negative 8 equals negative. Wait, did I screw that up? 8 times. Yeah, 8 times 4 is 32. So yeah, so that'll be 8. So that'll be x plus 4, x minus 8, and x plus 4, x minus 8. And let's just confirm that just to set that up correctly. I will double check that. We'll double check our work. That's going to be x squared minus 8x plus 4x minus 32 equals x squared minus 4x minus 32. There. Does that make any sense thus far?
Yeah, it's starting to, but it's
yeah.
Where are you pulling the plus or minus numbers from?
Well, the thing is that basically,
I think I know.
Yeah. Well, the thing is that basically we know that each of these is a factor for negative 32, right? Because the thing is that it could be 4 times minus 8 is negative 32, or negative 4 times 8 equals negative 32, right? So basically, what we do is we just you remember factoring a basic number, right? From like grade school math, like listing all the factors.
See, that's the problem. I was never taught that.
Okay. Well, the thing is, then what I'll do is give me a sec to find a way to clear this screen completely. Give me a sec to actually. I'll open a fresh file. Better yet. Let me open a fresh file here and new. No, I don't want to save changes. Okay, so let's run this to an even more basic one. Let's go with 64 here. Like we've already done a couple of examples with regards to the polynomials, but let's run basic factors of numbers. Okay, so we know that 64 is has multiple factors to it, right? Now the thing is that because of the fact that there are multiple, because of the fact that you can multiply both negative numbers together to get a positive as well as positive numbers. The actual number of factors. Okay. The default factors that we would assume for this are 1, 2, 4, 8. Now I'm just trying to remember. I think it was 4 times 16 was 64. Let's double check. Yep, there we go. So 1, 2, 4, 8, 16, and 64. But the thing, of course, is that because of the fact that each of these numbers has a negative counterpart, which when multiplied together will also equal 64, we literally have to go plus or minus because of the fact that the numbers can be both positive or negative. Phi, down from there. Down. Oh, Sigma up there. My mistake. Hang on, I'm gonna have to go get a cat. One moment.
Yes, they cause problems.
Yeah. So let me just put these in here. Anyway, so basically with the polynomial that we were dealing with there, what I was doing was that basically because of the fact that each of these is a possible factor of 64, by breaking it down, what we do is that we basically punch each of these factors into the polynomial that we were doing previously. And that will give us an example, and that will give us an idea of which of these factors of 64 is also a factor of the polynomial in question.
So now these specific numbers are I see it's the times 2 pattern. Is that pattern going to always apply, or did it just apply?
No. These are just numbers that happen to multiply together to make 64. I'm literally listing out all of the possible numbers that, when multiplied together, become 64. So, for example, 1 times 64. 1 times 64. Sorry, I missed one. Actually, I missed one. Hang on, I got to erase that because I missed a factor in there. That's going to be plus minus 32, and then it's going to be 64. So plus minus 32 and plus minus 64. So hang on. I knew I'd missed one, but thanks for calling me on that. So for example, if we're doing the number 64 just as an arbitrary number that we've picked, the factors will go 1 times 64, 2 times 32, 4 times 16, or 8 squared in this particular case. And basically what happens is that the 8 times 8. And basically each of these is a factor because of the fact that these outer ones, as you go in, multiply together to get the number 64. So these are all factors of 64 because they are all involved in the multiplication to get 64. For a polynomial, it's the exact same thing. You're just basically taking these numbers that happen to multiply together to get this number, and you're punching them into the polynomial to find out which ones work for the entire polynomial, not just for the number at the end. Does that make any sense?
What I'm just saying is I see that it's the 2 to 4 jump is times 2. Is that times 2 going to always apply for every number that you break down this way?
No.
Just apply?
No, it's going to break down by let's pick another one. Say 1 divisible by 3, right? Let's try 27. So with 27, it'll be 1, 3, 9, 27. It won't always break down this way, but basically the point is that each of these numbers multiplies together to get 27. Or you could have let me think. I'm just trying to think of one here that's 36 might be another one, which will give another example here. Let me put this here. So 1, 2, 3, 4, 9, 12, 36 divided by 2. Give me a sec here. Sorry, 36 divided by 2. 18. There we go. So 18, 36. So with this last one here, for example, the numbers don't always match up. It's not a multiplication by 2 that's the part of the pattern. The pattern is just all of these numbers. Are these numbers a factor of 36? Basically, as in, can 2 of these numbers multiplied together equal 36?
Okay.
You see what I mean?
Yeah.
So basically, in this particular case.
Okay. So I see. It's just the multiplication is going to screw me up because, like I said, my dyscalculia kept me from ever learning multiplication tables.
Okay. Well, yeah. So basically, the thing is that each of the thing is that each single one of these numbers can multiply with another one of these numbers to come up with 36. The reason why 1 and 36 are also included in there is because 36 times 1 is 36. So, but basically, yeah. But basically, each of these numbers will multiply with another one of the numbers in the chain to get the number you're looking for. And what you do with the polynomial, so for example, with that one that we just did, x squared minus 4x minus 32, with all of the numbers for 32 being plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16, and plus minus 32. What you need to do is that by being aware that each of these numbers could multiply with another one to get to 32, what you do is that you punch in each of these numbers into the general thing and see whether the whole thing adds up to 0. If it does, you know you've got a factor of the polynomial. If it doesn't, you know to go to the next one.
Okay, that helps.
Yeah. And then the thing, of course, is that if one of the minus numbers is your factor, then you go x plus that number. And if if the positive number is your factor, then it's x minus that number as your factor. When working the actual working the actual polynomial, it's always reversed in terms of the signage.
Yeah, that helps a lot.
All right, cool.
Because I the GCF got good or homework, but I'm not going to be able to do it in the test.
Okay, down cat, sigma down.
So a lot, dude.
Yeah. Well, while you're working, if you've got another example, or if you want, just go back over the previous examples I showed you. Try to work that for the x minus 4 x squared minus 4x minus 32. While I go grab the cat off the counter, and I'll be right back. Come on, sigma off, and stay off. All right, so I trust that made some sense.
Get it?
All right, cool. Well, at least we got to start now. Yeah, I was a little bit surprised that this factoring thing was hitting you so hard. Anyway, I'm going to sign off. I'm going to stop recording at this point. And to anyone who's watching inadvertently, hopefully this is the last. Hopefully this is an effective lesson for you guys as well. Right.